Okay, think we can get started. So hi everyone, welcome back to another week of Flashmath. Just as a heads up, I think this is gonna be the second to last class that we teach. Next time is gonna be probably the last time. So thank you guys for sticking around for so long. It's been lots of fun. Today we're gonna be covering trigonometry, which sounds really strange. I know, I teach algebra, not geometry, but it turns out that trigonometry in the AMCs and a lot of times the AME actually boils down to requiring a lot more algebra than it does with actual geometry. So today I'll try to stay away from the questions that ask for like the sign, trig with regards to like an angle. Instead, I'll just be talking about like trig as like its own like algebra, trig and what you can do with it algebraically and with their functions. So yeah, this like before, like last week, this one applies more to AMC12 and AME, but I think you guys will still find it really helpful, and it'll definitely be really helpful for like basic math classes, for like school math classes too. So all right, let's start with screen share. So here's the key for the homework. If you have any questions, just like probably don't submit them here. Submit them on the website. This was a pretty hard homework, I will say. So don't feel like really discouraged if a lot of these were like really tricky. So long as you got like the easy questions down, then that's already like really solid. In any case, I think we'll just like begin here. So let's talk about trigonometry. If you already know about, if you don't know about trig, don't worry. Hopefully you'll be able to it might help to have some prior knowledge, but I'll try and make sure that even those who don't know will still be able to follow along. If you do know about it, it's probably because you took some geometry class. And while trigonometry is really heavily related to geometry, and you'll see it like all the time there, a lot of questions about trigonometry involve a lot of things that you'll see more in algebra. So there are 6 main trigonometric functions. Sine, which one would probably write as, okay, sine, you'll see it as like sine x. Oh gosh, my stylus. It's like, so you'll see it as like sine x, cosine x. So that's for sine and cosine, and tangent would be written as tan x. These are all functions, by the way. Don't worry too much. If you don't know like exactly what they mean, then don't worry. Just think about them as just plain old functions. You have secant. Oh gosh. And then cosecant, and then cotangent. The two big ones here are sine and cosine. You can get everything else here with these two, but these two are like the really, really big ones that you have to keep in mind. And tangent, so the thing with tangent x is tangent x is equal to sine x over cosine x. Secant x, this part is really confusing. Secant x is actually 1 over cosine x. So it's just a reciprocal. And then cosecant x is the reciprocal of sine x. It's weird. That might take a moment to get your head around, but just make sure you memorize that part. And then cotangent is going to be 1 over tangent, which is just going to be cosine x over sine x. Okay, before anything, let's and if you don't really know what's now back to the actual sine and cosine. Sine x is a let's say it's a function that maps from any reals. So sine, its domain is all real numbers. I think, yeah, it's all reals, and then its range is actually strictly between -1 and 1. Same with cosine. Domain is also all reals, and then the range is between -1 and 1. We'll talk exactly about like some specific values in a bit, but that's just some like base knowledge. Now let's talk about a few identities that'll be really important. Probably the most important one are, these are called Pythagorean identities, but the really, really big one is this one. Oh gosh. Sine squared x plus cosine squared x is equal to 1. This is really, really important, and we'll probably like, and it comes up like time and time again. Then there are a couple other ones that you can actually derive from this. Oh gosh, like my pen is just not working. So 1 plus tangent squared x is equal to secant squared x. And then the last one is 1 plus cotangent squared x is equal to cosecant squared x. These two come up from time to time. I think this is a problem with Notability and not with my stylus, but like, these two, they come up from time to time, but I don't think they're terribly important. Like I can't really remember them off the top of my head most days, but this one is definitely the one that you want to know like the back of your hand. Now, some angle sums and differences. So we have sine x plus y. This is equal to sine x cosine y plus sine y cosine x. Oh gosh, that cosine just like completely disappeared. What the heck? And then, what is? Okay, technical difficulties here. I don't know why something like that. So cosine x plus y is equal to cosine x cosine y minus, that part's tricky, sine x sine y. Now for angle differences, hold on, just shrink this because I don't have enough room. Sine x minus sine y, minus y is sine x cosine y minus sine y cosine x. And cosine x minus y is cosine x cosine y plus sine x sine y. So those are really important. And I guess I could insert the one for tangent. There aren't really any, come on, work with me. For the other three, I don't think they're off the top of my head, and even if there are, they're probably not too important. But the tangent one is pretty important, as you'll see later. But tangent x plus tangent y is equal to tangent x plus tangent y. Over 1 minus 1 minus tangent x tangent y. Sorry about all the bugs, by the way. Like, I know there's a lot of like specs and stuff, and that's because like it's not really registering in like my finger. So that's the tangent one, and then tangent. I might as well just put in the subtraction one too. Over 1 plus tangent x tangent y. All right, so those are definitely really important. So make sure these two can actually be derived. Oh gosh, these two actually can be derived from these, and it might actually be a good practice if you want to try deriving them based off of these and the fact that tangent is equal to sine over cosine. But I got a lot to cover today, so I won't really stop to do that, but it might be good practice for you. We'll go to double angle identities. These can definitely be derived from these, because all you have to do is just put sine x and y as the same value. Just say both of them are x, and then you'll get this, and then you'll get the double angle identities. These are pretty easy to rederive. But they're still very handy to just know off the top of your head. So sine 2x is equal to 2 sine x cosine x. And cosine 2x actually has 3 different forms, depending on what you do. This one can be cosine squared x minus sine squared x. That's one way of writing it. Another way of writing it is 2 cosine squared x minus 1. I can't write a negative sign for whatever reason. And then the last one is 1 minus 2 sine squared x. And then tangent to x is equal to 2 tangent x. Come on. It's equal to that. I'll scooch it out just because it's kind of hard to see. But there, that's tangent. I know this is a lot of formulas, but just write them somewhere and just practice memorizing them, and eventually you'll get really comfortable with them. And if you want to find the ones that are for secant, cosecant, and cotangent, you can just take the reciprocal of the respective ones here. Half angle, you can actually, a lot of these are rederivable from these, from the ones for cosine. So in this case, sine x over 2 is equal to plus or minus. The positive or negative depends on like the context of the question, whether x is within certain ranges, but don't worry about that for now. Is equal to positive or negative 1 minus cosine x over 2. Cosine looks very similar. Oh gosh. Cosine looks really similar. Cosine x over 2 is positive or negative 1 plus cosine x over 2. And lastly, tangent is actually really nice. Once, like, this one's also derivable from if you take this one, this divided by that. I literally cannot draw straight lines. It's kind of glitching out. Tangent x over 2 is equal to 1 minus cosine x over sine x. All right, now for these last two, and these are definitely pretty tricky to know. And honestly, I can't even remember sum to product off the top of my head, or product to sum. But if you can remember these, more power to you. Like, these are really, really handy, and I would definitely recommend you try, at least attempt to memorize them. It's not the end of the world if you don't. Sine x plus sine y. Oh my God. All right, I'll slow down a bit, sorry. Here, let me just, I'll just zoom out like this. Okay, let's continue. So sum product, like I said, these are a bit annoying to memorize, but not terribly necessary, but you should at least like try to. So that's the first one. And cosine, sorry, I'm not talking much. Cosine x plus cosine y. That one's equal to 2 cosine x plus y over 2 times cosine x minus y over 2. I'll go back, I'll like scroll up and show all of the identities once I'm done, by the way. So cosine x minus cosine y is equal to, this one's a little weird, negative sine x plus y over 2 sine x minus y. Over 2. And last, product to sum. Cosine x, cosine y is equal to 1/2 cosine x plus y. Jeez. Plus cosine x minus y. Then cosine, sine x sine y is equal to 1/2. Oh my gosh. 1/2 cosine x minus y minus cosine x plus y. Next one, sine x cosine y is equal to 1/2 and then sine, cosine x sine y is equal to, actually that's like more or less the same as the above one. So actually, so you can just keep it at these 3. So let's just go back to the top and I'll like, yeah. Oh yeah, so here's the first part. I'll scroll down a little. All right, let's try out the first problem. Oh yeah, some notable values. I'll just point out the values where things are at 1 and 0, I think. And then, yeah. So for sine, just some values to know. Sine 0, it's gonna be 0. Sine, this next part depends on whether you're in radians or degrees. Sine of 90 degrees or sine of pi over 2 is equal to 1. Sine of 180 degrees or sine of pi is equal to 0. And then sine of 270 is equal to sine of 3 pi over 2 is equal to -1. And then sine of 360 is equal to sine of 2 pi is equal to 0. Actually, this the function of sine oscillates. So if you were to look at a graph like this, if you've ever heard of what a sine wave is, it looks something like this. So it goes from 0 to pi over 2 to pi to negative pi over to 3 pi over 2 to 2 pi, and then it repeats. The cycle of repeating, I think the cycle of repeating is known as a period. So it has a period of 2 pi. Cosine is pretty similar, except it starts off at cosine 0 is equal to 1. Cosine 90 degrees is equal to cosine pi over 2 is equal to 0. Cosine 180 degrees is equal to cosine pi is equal to -1. Cosine 270 is equal to cosine 3 pi over 2. Is equal to 0. And then cosine 360 degrees or cosine 2 pi. It goes back to 1. So there's the cycle. So the cosine graph looks very similar to sine in that except it's basically just scooted a little. So it goes from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. See if you can use this to determine the really important values for a tangent. And then since we're running a bit low on, since I really do want to get to the questions, just for fun, just write these down. Use Google to find the notable values for 30 degrees, 45 degrees, 60 degrees, 120 degrees, 135, and 150 degrees. Yeah, those values are pretty important. So just check those out when you have the time. All right, in that case, we'll get to our first question. This one's gonna be a bit of a throwback to last week, but I think you guys would still find it like decently manageable. So I'll give you some time to just like think about it. And yeah. Just Google the values for like, yeah. Okay, this one's tricky in that you have to remember both stuff about logarithms and stuff about trig, but let's just give it a try. So the first thing that you do when let's take the first equation and see if we can turn it into something that might be a bit more manageable. Pretend like that's a very clean underline, which it is clearly not, but yeah. So with this one, when you add, remember that when you add logarithms, you multiply the stuff on their insides. So we have log sine x cosine x is equal to -1. And then knowing this, so it's 10 to the -1, which is equal to 1 over 10, which is equal to sine x. Okay, geez. I cannot write. So this is something that will probably be helpful. Now let's move on to the next one. So this next part, so we have this. So first of all, let's see if we can simplify this right side into something that's a little bit easier to handle, because we actually can't do anything with the left side. So remember that we can turn 1 into log 10. And then when you subtract logs, you divide their insides. So you have 1/2 of log, log n over 10. And this can be further simplified when you realize that when you multiply it by like a constant, you raise it to the power of that thing. So you have log n over 10 to the power of 1/2. That's equal to log n over 10. The square log of the square root of n over 10. So we have sine x plus cosine x is equal to the square root of n over 10. So we have what they multiply to, we have what they add up to. Exactly where we're supposed to go next. Why don't we square both sides? Because sine squared x plus cosine squared x is equal to 1, and that's a really nice number to have. So let's square both sides. So on the left side, we'll have sine squared x plus cosine squared x plus 2 sine x cosine x. And on the right side, we just have n over 10. We know what this thing is because of that really handy dandy identity that we have. That's just equal to 1. And this part, we know what it is because of what we just derived here. It's 1 over 10, and then there's also an extra 2. So it's 2 times 1 over 10, so that's 1/5, is equal to n over 10. So n over 10 is equal to 6 over 5. That means n is equal to 12. Pretend that's a lot neater than it is. For the next couple of questions, I'm just going to kind of pick and choose, like which ones are better than others. I'll leave this one up for a bit though. I'll skip the next one for the time being, since I don't think it's terribly interesting, but I think this one's okay. Just as a hint, I'll write down the Pythagorean identities again, the two less important ones. And the other one is okay. This question is about to have some pretty big, like pretty ugly fractions, but we're gonna make it through. So from this first equation, we have that secant. There's actually a lot of ways to do this one, but I think this one is like probably the most clean, or one of the more clean ones. So we have this one from the Pythagorean identity, and then we can expand the left side with the difference of two squares. So on the left, this left thing is 22/7, which implies that this is equal to 7/22. So now we have like basically the thing where you have like a plus b is one thing, a minus b is another thing. Let's solve a and b. So except it's with uglier fractions and trig functions. Not nearly as fun, but well, what can you do? In the event that my iPad dies, by the way, like in mid-lecture, then I will probably charge it, let Andy do his lesson, and then then I'll just like wrap up some questions like right after him. Let's just hope that doesn't happen though. So anyway, we add these two together and then divide by 2. And I'll save you the computation that gets us this nasty thing. And then subtracting them and dividing by 2 gets you 435/308. Some pretty ugly fractions, but it's okay. Now let's see if we can derive cosecant and cotangent. First, we want to find cotangent. That's just going to be the reverse of this. the reciprocal, I mean. And as for cosecant, remember that it's 1 over sine. So now we want to find what 1 over what sine is. First, let's find what cosine is. So secant x is the reciprocal of cosine. So cosine is equal to 308 over 533. And then because tangent x is equal to sine x cosine x, what we can do is we have, if we want to find sine, we can just multiply cosine x and tangent x equals 435 over 533. Then to take the reciprocal of that, cosecant x is equal to 533 over 435. Phew, that's a lot of math. And then we can add these two together. Our result is 841 over 435. Believe it or not, this thing actually simplifies. Helps to know that this thing is actually 29 squared. So your result ends up being 29 over 15. And then to find m plus n, that's 44. I'm just going to scroll ahead real quick. Okay. I think we can do one more, but let's try this one. Actually, I think this one might be like a little overkill. So let's see. I'll keep the screen on this and I'll grab like a different option. Okay, yeah, got a better one. These are like, I think I'll probably keep these and just do them as like a part 2, but I think I kind of made a dumb mistake. So let's say that sine x plus sine y is equal to the square root of 5/3. And cosine x plus cosine y is equal to 1. And we want to find cosine x minus y. Just as a hint, don't use sum to product. That will just make your life worse. All right, the key to this one is thinking about how we can combine the sine x here from the cosine here. And that's a good place to start is let's just square both sides of both equations, like just square both equations. Generally, the squared forms of sine x and cosine x are like the easiest way to just like get them into a nice form. So the first one turns into sine squared x plus sine squared y plus 2 sine x sine y is equal to 5/3. Yeah, it helps that there's a radical here. It kind of even hints that, oh, maybe you should square it so that it becomes less ugly. The bottom becomes cosine squared x plus cosine squared y plus 2 cosine x cosine is equal to 1. Now let's add both equations. So sine squared x plus cosine squared x plus sine squared y plus cosine squared y plus 2 sine x sine y plus cosine x cosine y is equal to 8/3. And the stuff on the left, on this side, can actually be turned into like a much easier form. So like that just turns into 1, and that just turns into 1. So we have 1 plus 1 plus 2 sine x sine y plus cosine x cosine y is equal to 8/3. Now 2, this thing can actually is probably looks a little familiar, and that's because it is the cosine subtraction identity. So it's cosine x minus y. So 2 cosine x minus y is equal to 8/3 minus 2, because there's a 1 plus 1 on both sides. That gets us 2/3. And then cosine. Did I write it? Yeah. Cosine x minus y is equal to 1/3, which is our answer. Okay, we're kind of low on time. So since we're kind of out of time, I will just go back up to the for fun numbers and then like just talk through a couple of them. So these are really handy to just like know. Sine 30 degrees is equal to 1/2. Well, cosine 30 degrees is equal to square root of 3/2. And then tangent 30 is equal to 1 over the square root of 3. Then sine 45 is equal to square root of 2/2. And cosine is actually equal to the same thing. And then tangent 45 is just equal to 1. These four I'll leave to like be explored. And then and I guess that's probably it. Are there any other identities that you guys should kind of want to look back on? Guys, don't worry about the battery. I promise I have like a battery. I have a charger attached like right now. All right, in that case, that's all for today's trig. In that case, that's all for today's trig. And I know that was like kind of rushed, but yeah. I think I'll probably make next week's the part 2, in which case I'll just hand it off to Andy right now.